So I have a ready circuit over here with an LED and a resistor and a little bit of older code as well, which I'm going to delete for now because the code I'll be using is different right now. So this circuit here, we are actually creating a beeper and a blinker, um, right? And with the help of an input. And for input over here, we will be using a push button. So we already have an LED, and the code for the LED will be simple. Since it's set to 12, we can take this here, set it to 12, go to control, wait 1 second, duplicate over here and switch it to low. So this is your basic code of blinking an LED. In case you have any confusion, you can see this video again and create this. So we already have that. Now let's do one thing. Let's add a buzzer to it. Right. So over here, when you scroll down, you'll find a buzzer called piezo. It's a metallic plate which, when given the right frequency, will create a tone. So that's what a piezo is. You can study it up, and a link is available in your student central presentation. Now piezo is actually polarized. It has a positive and it has a negative. So you have to make sure the positive is connected to the pin, output pin. So let's take pin number 3 for now. Yeah, so let's put it connected to pin number 3. So the positive is connected to pin number 3. Please make sure, and negative needs to go to ground. So let's select one ground over here. Yeah, this seems like a reasonable GND pin that we can use. So that is your negative terminal of an Arduino, and you can use it for any other sensors as well. Right now we are going to use it for the output device of a buzzer. Now for coding the piezo, you could simply do the same thing you did for the LED as well. Just change the output pin number, right? So let's do one thing. Let's put it over here itself. So we are going to change 3 to high, and then we are again shifting 3 to low. So what should happen is it should make a sound for some time, 1 second, and then it should stop making that sound. So let's see how it works. Right. So that's the sound basically it makes when you give the values over here. Now if you see in the blocks itself, you'll find there are other pins as well, other block as well for the speaker. That is actually what piezo can use. So instead of sending the spin to 3 or to high, you can just switch that to play speaker on, and you can change the tone. Right now the tone says 60 for 1 second, and we can try it out how it works. So let's switch off the code and start the simulation again. Right, we have not written the right pin. The right pin is output pin is 3, and that's why it was not working. Start simulation. There you go. That's a very different noise from the one that was being made ahead, right? So you can go, yeah, so you can go with any of the choices. You can go with set pin 3 to high, or you can go to this one. For now I like this one, so I'm going to stay with keep with this particular block itself. So that's pretty much how your buzzer works, and that's your LED. So you have two components in place. Next thing that we need is an input, right? So we are going to go ahead and take a push button. So we are going to take a push button for this particular project. Now push button normally comes with 4 terminals. The key thing, or the most important thing to remember about push button, is they are diagonally connected. As in, to complete a circuit, your one wire, if it is stemming from terminal 2B, the other will have to stem from terminal 1A. So let's see how we can do with regarding the push button. I'm just going to reorganize my circuit a little bit so that my push button is at a place where I want it to be. So let's move this wire here, and I'm going to make my push button stay outside this wire. Alright, so I'm going to be taking the input from pin 2 of an Arduino, Let's change the color of this wire also, and I'm going to attach it to terminal 2B of the push button. You can choose either of the terminal as long as the diagonal terminals of the push button, one of them goes to Arduino pin where you are taking the input, and the other one, the diagonally opposite of that one, should go to the 5-volt one. So let's do that connection first. So as long as these things are, so let's collect this red since we are giving it a power of 5-volt. So as long as this is connected to 5-volt and this is connected to 2 and they are both on diagonal pins, it's all fine. But if you mess up in this particular connection, it might not work. If it is the other two diagonal pins, that will be also fine, but as long as they are diagonally connected. Now there's one more connection that we are going to take care of when it comes to push button. We are going to attach it to ground. We are going to take this terminal to A and we are going to attach it to ground. And we are going to actually put a high level resistor over here. So let's do 10 kilo ohm for now. And we are going to do a high level resistor here, and through a high level resistor, we are going to ground this pin. So here I come, and that's pretty much it. Let's change this color to, I guess, purple, and maybe we can change this color to orange. And that's your push button basically connected. Why did we connect it with a resistor to ground is we need any extra current flowing through the switch or any static electricity flowing through the switch to be grounded, to be sent to ground so that it doesn't malfunction or doesn't go bad in a few trials. So that is a chief reason why we put a resistor over here. However, you have to understand that the current flows in the direction where it faces the least resistance. So when we actually push the button, the circuit of this 5-volt to the pin number 2 will be complete every time we push the button, and that would be the easiest place for electrons to flow. So that is where the electricity will go, and only in the case when it is not pushed will the residue electrons or residue electricity, whether it is static, will all be taken to ground, and that way it will save our components from getting spoiled ahead. So let's code for our push button now, and let's code our first input. So let's go to code, and we're going to be taking input, right? So we need to read a digital pin. So, but this is pretty much an input block. So actually we need to again uh, go to control, and let's take an if block. And let's put an if, so every time a push button is pushed, only at that time our LED and buzzer actually works. So let's go to input again, but this will not fit here. So first a condition, and we need an equal to condition, and we need it to be high, and the input is going to be the digital pin. I'm going to drag this over here so you can see carefully. The pin number will have to be changed to 2 because that's where we are connecting our push button. So since this is connected at pin number 2, yeah, over here just change the pin number to 2. So what it will do is it will read the digital pin 2, see whether it is high or not. Only if it is high, high means it is pushed down, will the circuit work, will the LED blink, or will the buzzer ring. So let's see how it works. So here we are starting the simulation, and you can see nothing is ringing and nothing is glowing and nothing is happening. And the moment I start pushing the button, yep, and there you go.